Hello, everyone. So, our this discussion is regarding the reactions of alkenes. Previously, we have talked about the naming and IUPAC. We have seen how we can draw the structures of the alkenes and how we can name the alkenes. So now we are going to talk about the reactions of alkenes. So, alkene is from the class of hydrocarbons, which are also termed as unsaturated hydrocarbons because they do have uh, the multiple bonds, they have the double bonds. Alkenes, alkynes, and arenes, so they are termed as unsaturated hydrocarbons because they are not having all the sigma bonds, and the carbon is deficient with the hydrogen, and their deficiency is fulfilled with the multiple bonds, which is the double and the triple bond. So we may discuss the alkenes reactions and the reactivity along with the alkynes in some cases, but where needed, we will specifically focus on the alkenes and we'll see their mechanisms, and we will talk about in more elaboration in our future lectures about the alkynes. But more or less, the reactions and the reactivity or the reaction chemistry or the mechanism of the reactions on the multiple bonds which involve the double bond and the triple bond. So they are almost the same with the alkenes and the alkynes one. So currently, firstly, we will talk about the reactivity of multiple bonds, and that involves alkenes and alkynes both, the double bond and the triple bond. So the most characteristic reactions of alkenes and alkynes, unlike the alkanes, which we have discussed, which all have the sigma bonds, and each carbon is surrounded with the maximum number of hydrogens. So, as we see, to compensate its octet rule, when there's deficient, they are deficient in hydrogen. So they are making and they are filling each other's unfilled orbital through a pi bond, right? So these are basically the addition reactions, which can go with the alkenes and alkynes quite easily. And they are not in a case of the alkanes, because then in case of alkanes, when the carbon is surrounded with the maximum number of hydrogens, so then the one hydrogen has to replace, or that bond has to break to add another one. But right now here, there are the already available excess of electrons in form of the pi electrons, so they can easily accept the other reactant. So I have written in a generic equation. So the generic reaction for your easy and somehow in a more general understanding is that what are the kind of addition reactions. So addition reaction is a reaction when, let's say, this is a molecule and it has the pi electrons. That could be the double, that could be the triple bond. So, because in case of the double bond, there is one sigma and one pi bond, and when it is having the triple bond, that means there is a one sigma and two pi bonds. So, what it would be in that case? So, this, if there is any reacting molecule, so that could be the halogen, that could be hydrogen chloride, that could be the hydrogen. So what is happening, that this is adding into that pi bond. So don't confuse with that arrow, though in mechanism that arrow means that we have to show that which is the donor, which is the electron source, and where it is adding, right? So in this generic expression, this arrow direction is only just giving you the idea that this two atoms of C will add up to a B molecule, right? So now the in addition reaction product will be that these two atoms has added it to the originally first reactant, because it has the room for accommodating these two atoms by breaking its one double bond or the pi bond, and then they are making the two sigma bonds, with one is with the Ca and the Bc, right? So from this, you should understand that the addition reaction is that kind of reaction in which the one original molecule is adding up or taking up the other reactant in a way that this is not generating any of other products. So this is the whole product. A single product is came into being and resultant when it is taking up or it is absorbing another reacting species or another guest with its structure. So that is a generic form of the addition reaction. Now, more technically, according to chemistry definition, so what are the addition reactions? So right now we are explaining this addition reaction in terms of the alkenes, but you can write it according to the alkynes as well, or you can add the double bond and the triple bond if you are summarizing the addition reaction for both alkenes and alkynes one. So addition reaction, a reaction in which two atoms or ions react with a double bond, forming a compound with the two new groups bonded to the carbon of the original double bond, right? So what does it mean? We can explain it with that example. So in the equation, you can see there is the ethene, which is the two carbon chain, and there is a double bond between the carbon and carbon, right? And now it is reacting with a halogen, and here the halogen is the chlorine. So this do exist as a diatomic um, structure, and this is a molecule. So this is a Cl2, and these Cl2 are bonded to each other with a bond which will be broken, and then they are adding to the ethene. So here in that equation, you can see that the product is 1,2-dichloroethane, right? So what happened to this one is that this Cl has added it to this carbon, and one Cl has made a sigma bond with the C, right? So the product is the 1,2-dichloroethane, and the class of the compound we will call is the haloalkanes, right? So what is happening in this is that this pi bond has broken. So this is usually the radical reaction mechanism, and we will see its mechanism in our next lectures. But right now, we are discussing the overview of the addition reactions and some of the terminologies which are involved to explain that what kind of addition reaction it will be, right? So here the pi bond will broken, and there is the one electron on this carbon, there will be the one electron on this carbon, and the Cl bond will also broken in the um, radical formation. So this is called the heterogeneous cleavage, right? So I will explain that later. So what is happening that this Cl will make a bond with the carbon. One electron is shared by this Cl, and one electron will be shared with this C, and this will result in a sigma bond, right? So another one is the same is with the next another carbon. So if I just can explain you that what does it mean, the heterogeneous cleavage and the homogeneous cleavage, right? So here, when A and this is the A, right? They do cleave in a form that this is the half arrow and this is the half arrow, right? So half arrow means that they are taking the equal share. So this is the homogeneous cleavage when the both will have the equal share of that bonded electrons. So the overall broken bond break will be like this, that there is the A and this is the dot, and this is showing the A radical, and this is showing the second A radical, right? So this is the kind of homolytic cleavage, right? So this is the homolytic homolytic cleavage, right? And if it will happen in a way that there is A, and let's say this is the B, right? And that bond cleave in a way that B is taking the whole of this electron pair, leaving A as positive, because now this is deficient in electron, right? Plus B as negative, right? So this is basically the heterolytic cleavage. So in heterolytic cleavage, one is um, A and B, which are the bonded atoms. So they are not cleaved in a way that they are having the same share of the that electron pair which was making that bond, right? So this mechanism or this reaction will happen through the homolytic cleavage, because ClCl will broken in a way that there is the one electron on Cl and one electron on Cl, and same is with the C, uh, each carbon, and then there is the two new sigma bonds. So if there will be the alkyne, so what will happen, that there will be another step uh, to reach the alkenes. So the first product will be the haloalkenes, right? And the last, if we keep on adding the Cl2 into this one, so then that will result in the haloalkanes one. So now we will go for a table which is giving you the characteristic alkene addition reactions. So majorly the phenomena, or majorly the type of reactions which the alkenes undergoes, is the addition reaction, that the atoms, two atoms or the group of atoms, do added it or do combine with the alkene in a way that this pi bond will add these atoms or the group of atoms. So this is the addition reaction. But of course, depending on the reaction conditions, and majorly depending on what is the other addition reactant, or what is the atom or the group of atoms or the second reactor which is going to add on to the alkene, and what is our overall product. So on the basis of that, they have this addition has assigned a descriptive name. So here from this table, you can see that if the alkenes, there's an alkene, and if we combine it, if it react with any of the halogen acid, so that could be HCl. In generic form, you can write the HX. X means that couldn't be any of the atom from the halogen group. So right now in that particular example, we have written HCl, which is hydrogen chloride. So that could be HBr, that could be HI, HF. So you have to see the product. So what is the overall product is that the hydrogen has also been the part of that alkene, and the Cl has also added it to this one. So there is no removal and there is no second product. So it means that the whole of that species has added it, and that becomes the that became the part of that alkene. So that's why that is the addition reaction. This is simply added. This is not removing anything, like this is a substitution or the displacement or the condensation reaction, that it is eliminating the water molecule, right? So it means that is adding, and that is the part of this one. So on that basis, they have assigned the descriptive name. So sometimes they are the second product as well, but like for example, we will see in some of the reactions where we are adding the additional um, reactant, which could be the water and any of the solvent that could take part into that reaction. So then we have some of the product, byproduct, which will be the part of that reaction medium. So but general perspective, so any of the species, because this is basically the reactive molecule, and that is becoming the part of that product, that reacting. So that's why these are the addition reaction. So the first reaction is hydrohalogenation, means there is the hydrogen which will also be added it along with the halogen. So this is called hydrohalogenation. So in this case, you will get the product which is the halide, right? So there is the haloalkanes as a class, you will get that one. So now the second reaction is this one, when the alkenes are reacting with the water molecule, and we know the water dissociable in the H positive and OH negative. So again, that this H and OH is a part of that alkene, and this is called the hydration. The basic or the background or the theme of this reaction is, the origin of that reaction is addition reaction, but these are the descriptive, because now this is a specific reaction that alkenes are reacting with the water. So with addition of the water, so we can specifically mention it as a hydration. But what kind of reaction in the general scenario is, in terms of the chemist kind of types of chemical reactions, so this is the addition reaction. Now we will see the third example. Here the alkenes is reacting with the halogen with no additional molecule. So then there is the addition of these halogens on with the both carbons which were in the double bond with each other, which were having the pi bond. So now this is called in general term the halogenation, but right now in this specific example we are using the bromine, so that will call the bromination. If we are using the Cl, so we will say this is the chlorination, and if we have used iodine, so then that will be the iodination. So general term is halogenation. This is giving you the idea that any of the halogen, if added it, so this is simply the halogenation. So if you're specifically mentioning that what is the exact reactant, so then you have to mention it is the bromination or chlorination or iodination. Now the next is almost the same one, but now we have added an additional molecule here, and that is the water, right? So now we will see that what kind of product happen when we are combining the alkenes with the halogen in the presence of water. So here that is the bromohalohydrin, right? So bromo is specifically for this reaction. So you can say this is the bromohydrin, which is the product. So hydrin is a term we use for when there is the hydroxyl and there is another atom which is attached to it one. So halohydrin are the kind of the product when there is the one halogen and one hydroxyl group which has attached to that one, right? So here this is the bromohydrin formation, and the bromine has added it to the alkene and the hydroxyl has added it to the alkene one, and the byproduct will be there is the acid which will be removed in the form of HBr. Now the next one is oxymercuration, right? So in oxymercuration, we are using the mercuric acetate in the presence of the water. So this is not a single step reaction, so it involves the 2-3 steps, and then we will see in our next lectures that what is exactly the mechanism of these kind of reactions. So here this this oxymercuration is a product. So here the water hydroxyl from the water has also the part of the alkene, and one molecule of this AgOAC has attached to this carbon, right, leaving the one acetate side which will be combined with the hydrogen of this water molecule, and this will be the acetic acid in our reaction system. So that will be the part of this one. So that is also some interesting reaction that they are facilitating for the acidic medium of the reaction system. So here this is the oxymercuration reaction. So you should know that in oxymercuration type of addition reactions, what would be the product when you are reacting alkenes with the mercuric acetate. So the next one is the hydroboration. Hydroboration means there is a boron which will be added, and the hydrogen will also be the part of that alkene, and we will get the alkanes generally, but they are the boroalkanes. So these are the hydrogen which is also added to it, and there is a BH2 which is the part of another carbon. Now another one is the osmium tetroxide, And this is the kind of reaction in which the osmium is not the part of the product, because this is catalyzing that reaction in a way that is the source of this oxidation reaction, right? And there is the 2-diol which will be added to the carbon one. So whenever you are interested to make the diol formation, means the dihydroxy alkanes, so then you should know that you have to treat the alkene with the osmium tetraoxide. Now, another one is the reaction of the alkenes with the hydrogen. So with the hydrogen, that hydrogen, two atoms of the hydrogen will be the part of the alkenes. So simply they are satisfying the carbon with the maximum number of hydrogen. So now these are the alkanes, and this is called hydrogenation, and this is called the reduction reactions also, right? So though there is they are the different kinds of reactions which the alkenes and alkynes going through. So the major are they are the addition kind of reaction, but more specifically depending on the reacting species and the reaction conditions, they come out as the oxidation or the reduction or the halohydrine or the diol formation. So that's why they have assigned the descriptive name to these reactions. Now we will define the mostly alkenes are going through the electrophilic addition. So we have to define that when we will assign the name electrophilic addition rather than the simply the addition one. So a common type of reaction with alkene in which an electrophilic species adds to a pi bond, right? So you have to concentrate on this term, that what is the electrophilic species is. So electro is means this is electron, something related with electron, and the philic is a term we use for the loving, and it has the interest for. So electrophilic means that is a species which is looking for the electron. So if it is looking for the electron, it means on a background its self, this is somehow deficient in electron. So that's why this is looking for the electron partners to complete its stable formation or to complete its octet one, right? So whenever an electrophilic species is adding or it is becoming the part of that pi bond and forming a product when reacting with the alkenes or the alkynes, so this is called electrophilic addition. But we have to see that how we know that this is electrophilic species. So there are the three common characteristics by which you can you may know about the species, that this reacting species is electrophilic in nature. So there are some of the visibilities, and for some you have to work on its octet one, so you can see its Lewis structure. So either they are fulfilling their octet one or not, either they are having some charges. So on the basis of that one, you can decide that these either that is the electrophilic species or not. So right now we will discuss these one. So the first one is a region of low electron density reflected by a partial or full positive charge. So here I have put some examples for your understanding. So a positive charge with an acidic hydrogen. So there is the oxygen which is sharing its non-bonding electron, extra non-bonding electron, though it is allowed to make the two bonds, but now this is sharing its non-bonding or the lone pair of electrons for making an extra bond with the hydrogen. So that's why this is getting deficient from its original configuration with the two electron less. So that's why this is getting the positive, because this is donating electron pair to the hydrogen one, right? So that's why this is getting the positive charge. Now, if you just look at the HCl, so here the chlorine and H, this is not ionic, this is the bond in terms of when there is the partial negative and the partial positive charge. So there are the electrostatic charge, but they are not the fully positive and the fully negative, because hydrogen is also sharing the electron with this one, and the Cl is taking up that electron for completing its octet one. So they both are completing their octet by the mutual sharing, not just ionization or totally giving that electron to the chlorine one. So that is a kind of, that is the polar ionic bond. And here you can see that H is getting the partial positive, and Cl is getting the partial negative, because they are not completely giving or taking up that electron, so they are mutually sharing, so they are in a shared position, so that's why they are assigned the partial positive and partial negative charge. Now the next one is the mercuric acetate. So here, this is the mercury, which is getting the positive charge because it is making a bond with this one, and this is getting deficient, right? And this is with the Lewis acidic mercury atom, because now this is linked with oxygen, which is highly electronegative one, right? And there is the carboxylate side. So oxygen has the high electronegative, so that can pull up that electron density towards itself. So as we have stated, that could be the low electron density, so it is reflecting with the full or the partial positive charge. Now the second is the lack of an octet on an atom, means that the atom is not having its completing its octet one. So this is deficient to complete its octet one. There still need for more electrons to complete its octet one. So then, even then, that species will be electrophilic. So here, this is the hydrogen borane, right? So this is the BH3. A boron is basically not in the complete octet form. This is still lacking in the electrons to complete it. If you count these bonds, so these are the 2, 4, and 5, 6. So there are the 2 more electrons, so it can complete its outermost shell. So the next example is, again, this is the C carbon, which is bonded with the 3-methyl group, and the carbon can make the 4 bonds with to complete its octet one. So right now this is deficient with an atom, or either even that is not able to make the double or the triple bond. So that's why this is assigned the C positive, and this is called the carbocation. This type of carbon which is having the positive charge, this is called carbocation, and that is very much important in our mechanistic studies, and we will talk about that, how the carbocation species are deciding the rate determining steps, and in our next maybe courses in the 261 or organic chemistry 1 and 2. So how they are moving towards the mechanistic substitution and elimination reactions. So a positive charge on a carbon atom that is lacking an octet one. So these two are the examples when the atom is deficient to complete its octet one, and these are when it is assigning or getting the positive and the negative charge. A third characteristic is that one when there is a kind of bonding which is weak to an atom, and they can easily depart as a stable ion or a molecule, right? So here, this is a CH3 and I. So a weak bond between a carbon and iodine atom. So there's a question why this is weak, because there is not a significant electronegativity difference. So they have almost the same kind of electronegativity, and they are because iodine is very much big in size, so that's why they have the distance from each other. So this nuclei, this electron pair is very distant apart from each other, so that's why that can easily broken. So iodine as I negative can do exist, and the CH3 as a positive ion can also do exist, and that can easily broken, and then eventually they will go for making another bond. And even if they are in a radical form, then they can exist, they can survive rather than comparatively to the other species if they are in a strong bonding. So these are the 3 characteristics by which we can assign that either that species is electrophilic in nature and that is electrophilic addition or not. So now we will discuss the one of the reaction, addition reaction, uh, and that is the hydrogen halides. So the reaction of alkenes with the hydrogen halides, and what kind of products we are getting, and what are these characteristic of these reactions. So we will simply see when the hydrogen halides, so these are also called the halogen acids, right? halo acids. So that includes HCl, HBr, and HI. We are skipping HF from it because HF is very strong reagent and that reaction is uncontrollable. So that's why mostly we talk about the hydrogen chloride, hydrogen bromide, and hydrogen iodide to add on alkenes to give haloalkanes. And these are also in a common name, they are termed as alkyl halides. So in organic chemistry 1, you will talk specifically about the alkyl halides, more exclusively about these one. So these addition may be carried out either with the pure reagents or in the presence of a polar solvent such as acetic acid. Means that either we can just directly combine these two halogen acids and alkenes one, or we can use the sum of the solvents, the polar solvents, for making it feasible, like the acetic acid. So here the ethylene, this is the ethene, right? And this is combining with the HBr. And here you can see that this H is becoming the part of one carbon and the second carbon is getting the Br. So the product is the bromoethane, ethyl bromide. That was the simplest and the basic alkene, right? So there is a technical term, or there is a more specificity when we talk about the more higher chain alkenes. So what would be the preferred product in that case? So here the both carbons are equivalent. So either Br can be attached to this side or the H. So whenever we are assigning the number or we are naming, so that will be the same one, right? We always have to assign the one carbon to that carbon which is having that major substitution, and that is the bromine one. So when we are talking about the propene, so this is a case in which this carbon, doubly bonded carbon, have the two distinct sides. So one side is the terminal one, which is just at the corner, and this is open end. And there is one carbon which is doubly bonded, and this is surrounded one. This is substituted with the one methyl from this side, and this is making a double bond with this carbon, right? So when it is reacting with the HBr, so what kind of product it can have? So there are the two possibilities of the product. So this hydrogen is attacking on this carbon, and this Br is combining with this carbon. Another possibility is this one, that this hydrogen is attacking on this carbon and the bromine is attacking on this carbon. So here, the two kind of products can be formed when the propene is reacting with the hydrogen bromide. So there is a two bromopropane and there is one bromopropane. So here this is written not observed. So that point we have to address with why we are saying that this is not observed. Though in our opinion, when we are talking about this reaction, so both are having the pi bond. So why not this? Why not the one bromopropane? So what is the reason for this one? So this kind of products, this kind of reactions, when the one product is basically the major, this is the more predominant one, and it has a preference over the other product formation. So these kind of reactions are called regioselective, right? So regioselective means they are specific for the site where the halogen or any of the electrophilic species has to attach and where the hydrogen has to be the part of that carbon. So this regioselectivity was described by a scientist who was the Vladimir Markovnikov, who made the generalization known as Markovnikov rule, right? And this is a very famous rule by which we can decide that what kind of product we will get um, out of that reaction. So mostly in your exams and when you are doing your research, so you have to be um, you have to decide that what is your preferred product and you are asked for it. So you should know that either that product is formed through the Markovnikov rule or anti-Markovnikov rule. So right now we are talking about the Markovnikov rule, which was explained, which has explained the regioselectivity and the preference of the species which are adding to the alkene. So regioselective reactions are the reactions, an addition or substitution reaction, in which one of two or more possible products is formed in preference to all other that might be formed. Reaction of HBr with propene, which we have discussed in our previous slide. So that is something that this is not always the case that only the one product will be preferred and predominant, and there will be no other product forms. If they are having the high opportunities or the high chances for all kind of products, so there could be the difference in their percentages, in their yield. Like for example, the one product which is a major and predominant, that is around the 80% in yield, that has formed in 80%, and the other one is just in a 20% and a 10%. So that preference again is the regioselective, so which is your major product. So that is true, the regioselective reactions. So this regioselectivity was explained by the Markovnikov rule. So whenever, in a generalized form, whenever an hydrogen halide HX is added to the alkene, so hydrogen adds to the double bonded carbon that has a greater number of hydrogens already bonded to it. Although Markovnikov's rule provide a way to predict the product of many alkene addition reactions, but obviously there is no you can say the concept for it. So these are the generalization which was formed on the observation of the reacting species and the reaction mediums and the conditions. So generally, whenever the alkene is reacting purely with the um, hydrogen halides, so basically this is reacting in a way that hydrogen will be the part of that carbon which is already have its family members, like which is already had the higher number of hydrogen. So and the next part of this one will be added to the carbon which is having the least number of hydrogen. So in general understanding, we can assume, because the other reactant, hydrogen is a very simple and very small in size, right? So that could be that prefer to be the part of that carbon which is already surrounded with the same like of atoms, to not create any disturbance. And when this is the carbon which is the substituted one, which has the least number of hydrogen, it means that the other part of that reacting species, right, which is the bigger than the hydrogen one, so there is only one window, so that could be the part of it, and that they can rearrange, because then that simpler or the smaller in size atoms will be able to adjust when this in a spatial rearrangement, that molecule reorient its geometry according to the tetrahedral form, right? So that can stabilize its geometry. So it means we can say that that could be the reason why they prefer to be on the part of it. So if that reaction is happening, and if the product in that way, that the reacting hydrogen has added it to that carbon which already has the higher number of hydrogens, so and the other one, the halogen, is the part of that carbon which is having the least number of hydrogen, so that is according to the generalization. This is not disobeying, or this is basically following the Markovnikov rule, so that is called Markovnikov addition, right? And if it is not fulfilling that one, if it is opposite to that one, so then we will call it anti-Markovnikov addition, right? So right now, this is the Markovnikov addition. So the product we are getting is 2-iodo, 2-methyl propane. So at last, we have a task, and you have to tell me according and keeping in mind that what would be the preferred product when we are reacting the alkenes with the HBr. And now if you just look at this example, these both are having the cycloalkenes, cyclic structures, right? So this is basically the cycloalkene, but this is not the cycloalkene. This is having the substitution of cyclic ring, and this is basically the methylene, right? So here you have to tell me that what is the product, keeping in mind that it has to follow the Markovnikov rule, It is a radioselective reaction, and it is an addition reaction. So HBr and HI has to be the part of that original alkene. So you have to submit that task and you have to answer this one. So this is a MCQs type of reaction. I have given you the options in the Google Classroom. So you can attempt that, and then I will let you know what either you are on the right side or not. So take care. Have a good day.